So let's take a look at this 4.6 optimization problem, right? So let's look at a similar problem. Let's see what happens if we do square root of x again, y equals square root of x. And let's use the point 20 here. And we want the minimum distance from that point to the curve. And we want to show that that min distance will be perpendicular to the tangent line. What should we call this point here that we don't quite know of? It's unknown, right? Yep, x and what? Good, x and f of x, right? So whatever the function turns out to be. And this was that kind of that second step in my step-by-step, right? Where I said, oh, use the equation to help you find the function to optimize, right? And we have memorized our distance formula, or better yet, we have it on our formula sheet, right? And the easiest way to write it down quickly is delta y squared plus delta x squared, square root of that. So it's just a Pythagorean theorem, right? That's the quickest way to think of it. And of course, delta y is y2 minus y1, right? Delta x is x2 minus x1. We know that from, I don't know, 7th grade, 8th grade, right? Depending on what you were doing. So we get our distance formula. What's my delta y? Who sees it? That's my delta x, but that's fine. So x minus 2 squared, right? And delta y is? Nice. And that quantity squared. So this one's turning out to be the same, but we're going to go one step further with it than what we did yesterday, okay? Everybody okay here? Yeah? Not, you're okay? I mean, you didn't see this yesterday, or maybe you watched the video, but you're okay with what I'm doing? Okay. So I try and simplify this if I can. I get an x plus an x squared minus a 4x plus 4. So my final distance formula is square root of x squared minus 3x plus 4. And what do I know right away about this distance? What can you tell me? What are the properties of this particular function? The distance can never be 0, right? It could only be 0 if my point was on the curve, right? And d of x has no max. Of course, you could tell this distance is never 0 graphically as well, right? You could graph the whole function, or you could just graph the parabola. Yes, you with me? So if I graph the parabola, if I just graph the parabola, y equals, and I'm going to put parentheses around it for a reason. Help me, x squared minus 3x plus 4, right? So you could see my parabola also already doesn't hit 0. So square root of something that's bigger than 0 is bigger than 0, right? And then what I'll do is I'll throw a square root in here, right? So 0.5. And then again, you can see my distance is never 0. It's above the ground. It's above the x-axis, right? And it looks like my min distance is somewhat bigger than 1, right? Do you agree with that? Yep. So what was our next on our list? Now that we have our function in one variable, yes? Say it again. Exactly. It's the distance from that point to anywhere on the curve. Anywhere on the curve. Exactly, is the min distance. Yes, it's going to minimize the length, right? The length of that segment, right? But then we're going to use the x value there to get the coordinates, to get the distance, to get the sign, SIGN, of the second derivative. Okay, so we're going to find our derivative. On your mark, get set, go, please. Don't copy, do. And of course, I like that general, whenever I can, I like to write the derivative referencing the original function, if possible. How do we go? We do all right there? Yes? So we need a critical value. So d prime of x equals 0 implies 2x minus 3 equals 0, which means x is what? 3/2? Of course, d prime of x dne doesn't exist, right? Right? There's no need to look, right? Because we already know downstairs cannot be 0, right? So the derivative does not exist when the denominator is 0, but this one can't be 0. Well, we can do a couple of things here. We can find the distance now. We can find the, I kind of want to go like this. I want to go to my Desmos and type in x equals 3/2, just before I go further and make sure I'm not using the wrong point. You know what I'm saying? I want to be able to check myself as I go so that I'm not wasting time. Like if I had 2/3 here instead, right? If I just did one of those little dyslexic things where I just flipped, you can see it's not right. So it gives you a chance to go back and say, hey, wait a minute, right? And when you're practicing, if you don't have, like if you go back to your university next semester and you don't have this stuff, you're not in a room with computers, or they don't let you use a calculator, you still want to be practicing with that, right? Practice with it. And you're going to get good at calculus without the machine, right? So, looks like we should be able to find our point, right? So what was the point on the curve, right? We had 3/2, comma, square root of 3/2, right? And of course we could rationalize that. Square root of 3 over square root of 2 is square root of 3 over square root of 2 times square root of 2 over square root of 2. You remember doing that in trig, right? Use that downstairs radical over itself. So I get square root of 6 over 2, right? And again, it's just me being a super nerd. Me not being too lazy about it, right? We want to be consistent and be precise and be elegant. So we're now going to just check that point and see if I've got the right point on my distance function, right? So 3 over 2, comma, square root of 6 over 2. Yes, what did I? Looks like I'm wrong anyway. How'd you get square root of 7? Oh no, that's their that's our distance. Oh, you're right. I'm making a horrible mistake. Sorry. I actually want to see this point on my square root function. Thank you. So y equals square root of x, and that's making more sense. That point that I had is not the min distance. It's the x value for the min distance, right? The y value would be the distance, correct? So let me fix that. So the point that's the point on this on the original function. I had it right. The min distance, right, is d of 3/2. So that's the square root of 3/2 squared minus 3 times 3/2 plus 4. So I get 9/4 minus 9/2 plus 4, all in the radical. I'm going to get everything over 4. So 7, yes, square root of 7/4 or square root of 7 over 2. That's the point, right, that should be the min point on the distance formula, right? Is that making sense? I know it's confusing you a little bit there, but I'll put that one in. So 3/2, comma, square root of 7 all over 2. There's the min distance. Everyone okay here? No, no one's okay. Anyone okay? Good. What's that? The blue point. So remember, the original problem, we're trying to find the point on the curve that's the min distance from the point 2, 0. Right? And so I have figured that out, right? That is 3/2, comma, square root of 6 over 2. We're trying to find the min distance. We found that, right? Min distance we found. That is d of 3/2, and we got that as square root of 7 all over 2. We want to verify that we definitely have a minimum, right? So how do we do that? So if d of 3/2 exists, right, it's a real number, and d prime of 3/2 is 0, and d double prime of 3/2 is positive, then x equals 3/2 is a minimum. So we have already that d prime of 3/2 is 0. We found the distance at 3/2. That was square root of 7 over 2. All we have to do is find their second derivative at 3/2. And make sure you remember, I want to use my general form of the derivative, which turned out to be 2x minus 3 over 2 times d of x. Right? So let's do our quotient rule to get the d double prime. Not copying, you're doing it yourself. So once we find d double prime, how do we do with that? We find that? We get the same. Nice. So d double prime of 3/2 is 4 times d of 3/2. We know that number. Minus 2 times 2 times 3/2 minus 3. Well, that's 0. And d prime of 3/2 is already 0. So all of that piece goes away, right? This is all 0. So I have d double prime of 3/2 is equal to 4 times the distance at 3/2 over 4 times the distance squared at 3/2. Of course, the 4 goes away, and one of the distances go away. So I get 1 over the distance at 3/2, which of course I know is square root of 7 over 2. So I get 2 over square root of 7, or better yet, 2 square roots of 7 over 7, which is definitely positive, right? D prime of the critical value is 0. So remember how we're trying to find a critical value. We set the derivative equal to 0. Right, and you can see that up here. I'm setting d prime equal to 0, so and I get x is 3/2. Nice. So we could make some conclusion here, and I'd like you to, right? Yada, yada, yada. We did it a couple times yesterday, so. But I want to now show that the tangent line to the curve is perpendicular to that min distance, that segment, right? So how do I show perpendiculars? You remember? You remember the relationship between perpendicular lines? Something about the slopes? Opposite reciprocals. So I want to show the segment has a slope that's opposite reciprocal to the tangent line, right? So look at what I've got. I got my square root of x function. I got my point 2, 0. I have my point 3/2 square root of 6 over 2. And I want to find the slope of the segment and the slope of the tangent. And then compare them, right? Show the slope of the segment is the opposite reciprocal of the slope of the tangent. Well, let's get the slope of the segment, right? Well, I've got 2 points, so it should be easy, right? So square root of 6 over 2 minus 0 over 3/2 minus 2. So the opposite of square root of 6. Can you agree with me there? Can you do that calculation for me, please? Don't just look at mine. Do it yourself. Our derivative of square root of x is 1 over 2 square roots of x. So that's f prime, right? So the slope of the tangent is going to be f prime at 3/2. So that's 1 over 2 square roots of 3 halves. So 1 over 2 square roots of 6 over 2. That's 1 over square root of 6. Look at that. I already know it's opposite. One's negative, one slope is negative, one slope is positive. And it's definitely reciprocal. One is square root of 6, the other one is 1 over square root of 6. Nice. Tough problem, right? Yes, question? Go back? Yep, sorry. Nice. There's one like that on every final exam, so look at them all, okay? Do them all. Looking at our outline for today, I guess we're ready to jump into chapter 5. Chapter 5 is all about integration. And you know already, just kind of me forcing it on you, integration means undoing a derivative. To integrate means to undo a derivative. So first thing I want to talk about is the fundamental theorem of calculus. This is 5.4. You remember the fundamental theorem of algebra? Anybody remember the fundamental theorem of algebra? All polynomials can be factored down to single factors with multiplicity, and the factors could be real, meaning rational, irrational, or they can be imaginary, right? So you can factor down every single polynomial down to single factors. Fundamental theorem of calculus says if I am taking the integral of a derivative, I get back the original function. So what is this saying about derivatives and integrals? What does this one say on the right-hand side? What do you read on the right-hand side here in black? What do you get there on that right-hand side in black in that last line? Do the calculus for me. What do you get? F prime. So what does that have to say? What should happen on the left side? Huh? So I already know the right-hand side should just be F prime. So what's going to happen on the left side? Say it again. I can't quite hear you. No, not second derivative. What's that? They cancel out. The derivative and the integral are inverse operations, right? derivative, integral, cancel. Dx over dx, cancel, right? Right? Do you see it? So the first part of the fundamental theorem of calculus says that getting a derivative and getting an integral are inverse operations. They're inverse operations, they undo each other. Here's where it gets weird. The integral from a to b of f prime of x dx, say again? Thank you. Is f of b minus f of a, which is the area under the curve. This is important that you think about it, not that you really agree or understand it yet, but it's important to think about, and it should bother you a little bit. It should bother you a little bit, because it's weird. When I have a function and take the derivative, what do I get? I get a function that gives me the slope at any point of the original function, right? Now I'm saying if I start with the slope and I get to the antiderivative, the original function, I get the area under the slope curve. What? Derivative gives me slope, antiderivative gives me area. It's crazy to think about. Yes? Yes. So, but the original function is giving me the area under the slope curve. Yeah, when I ask for an integral, I'm looking for that area here in green, right? And how do I find it? I integrate and evaluate at the endpoints. And I'm going to do a bunch of them, so don't worry yet, okay? But we want to have this thought of, right? To get the slope of the original function, I need to find the derivative function. To get the area under the derivative function, I need to get the original function, right? So somehow, slope and area are products of inverse functions. This is weird. It doesn't make a whole lot of sense yet. All right, so what we want to do is we want to start real simple with something called the area problem. So this is 5.1, the area problem. And you'll see in your fields, integration is going to give you different kinds of results. Sometimes a number, sometimes an area, sometimes a volume, right? And we're going to do all of these applications of integration in Calc 2. For computer scientists, we're talking about integration giving us probabilities of events. Very important, of course, right? So all kinds of applications to your fields of study. Of course, in physics, it's going to give me a force, right? Oh, electrical engineering, right? So, but it's going to give me, it's going to, it's going to tell me voltage, amps, things like that, intervals. It's crazy. So the area problem. Let's take a look at a nice simple problem. Let's say y equals 2x. from 0 to 2. So we're looking at the integral from 0 to 2 of 2x dx. Well, this is a power rule, so we can do this. We can do this one right away, right? What's the antiderivative of 2x? Yeah, x squared. So I'm going to add 1 to my power, divide by my new power, and evaluate at 2 and then at 0 and subtract. And so this is a new notation for us a little bit. So I get x squared evaluated at 2 and then 0, and then I subtract. So 2 squared minus 0 squared. So I get area of 4. I can double check this with Desmos. And so you should try this at least once with me before you go home. I'm typing int for integral. It prompts me for the lower bound and for the upper bound, and then I'm writing 2x dx. Oops. And of course it gives me 4. Yes? Yes. Yeah, that's so I'm calculating the area, the original function at the endpoints, and then subtracting them. Yes. So I get the antiderivative of x squared. I evaluate it at 2. I evaluate it at 0. I subtract. That's what gives me my area. Say again? There is a plus c. That's a great question. So I can really think of this x squared plus c, right? But when I evaluate it at 2, I get 2 squared plus c. And then I evaluate at 0, I get 0 squared plus c. And then what happens to the c's? Yeah. Yep. Now, what I want to do is I want to just calculate this area. This is a triangle, right? What's the height? It's 4, right? 2x evaluated 2 is 4, and the base is 2, right? So the area of the triangle is 1/2 of the base times the height, so 4. That's right, the antiderivative, right? The function that you originally took the derivative of, yes. That's right. So the fact that the integral, and by the way, this integral is called the definite integral. Whereas if I just did the integral of 2x dx and got x squared plus c, that's called the indefinite integral. And we will often just say integrate this, right, to get the original function back. I won't say find the indefinite integral. Well, we don't waste time doing that. If you see the bounds, you know it's a definite integral. It means I want the area. If you see it with no bounds, it means I want the function, right? Is that making sense? If I see the integral with the bounds, that means I want the area. If I see the integral without the bounds, it means I want the function. All right, here's the area problem. the integral from a to b of f prime of x dx is equal to f of b minus f of a, but that's approximately equal to the sum from I equals 1 to infinity of f of x sub I times delta x. Where f of x sub I is the height of the rectangle, delta x is the base of the rectangle, I'm sorry, I equals 1 to n, I'll say. And of course, height times base is the area, right? I use right-hand rectangles only. In the book, there's right-hand rectangles, left-hand rectangles, and midpoint rectangles. Before you get into Calc 2, make sure you go over all three of them. Know all three of them before you start Calc 2, which is only 1 week later after we finish, right? But I stick to right-hand rectangles only just to simplify it, okay? What do I mean by right-hand rectangles? So if we look at our same problem as before, and I'm going to choose to use 4 rectangles, I go up to get the height of the rectangle on the right side of the rectangle. Yes, you can see that the top right corner of my rectangle is getting me my height. And so this is x sub 0, x sub 1, x sub 2, x sub 3, x sub 4, right? Each tick mark is marking off x sub I. So I is the index. Delta x is b minus a over n. N is the number of rectangles. X sub I is delta x, a plus delta x times I. And of course, f of x sub I is the function evaluated at each of those. Very, very strange at first. It will get better, okay? It'll get better. Things will start to click for you a little bit. Yep. Don't let me run you over though. Don't let me run you over. If I'm way past you, stop me, okay? Now, if you look at my 4 rectangles here, do I have too much area or too little area? Too much area. Guess what? If I used left-hand rectangles, I'd have too little. So the 2 sets of calculations will give me an overestimate and an underestimate. And if I go more and more rectangles, I get exactly the amount. Yeah, so look at the red triangles. You see, I want area under the curve. It's giving me some area above the curve. So too much area. Let's see what happens if we use 4 rectangles here. So the integral from 0 to 2 of 2x dx right? Let's see what happens if we have the sum from I equal 1 to n of f of x sub I times delta x. Let's see what happens, right? So first of all, I need delta x. What is it? I'm going to use 4 rectangles, right? Yeah, so it's 2 minus 0, b minus a, all over the number of rectangles. So 2 over 4 is 1/2. Notice in my picture, the black lines are 1 and 2, right? The width of each rectangle is 1/2. Good. X sub I is a plus 1/2 times I. We're using the start of the interval, so a is 0, right? We're going from 0 to 2. We're using a plus delta x times I. So the first time I'm calculating my height is at what x value? Well, I is just an index, so 1/2 times 1, so 1/2. Say again? Index, counter, first rectangle, second rectangle, third rectangle, fourth rectangle. My second index is what? It's 2, so 1/2 times 2, right? My third is 3, so 1/2 times 3. So you can see it once I get my delta x, right? I'm talking about 1 delta x, then 2 delta x's, then 3 delta x's, and 4 delta x's. What's my x sub 4? It's 1/2 times 4, which happens to be what? 2. That's what my endpoint is. So you can see what I'm doing here, right, is I've got 1/2, 1, 3/2, 2, right? And I'm calculating the height of each rectangle at those values. And remember, my height is 2x, right? So this is a height of 1, right? This is a height of 2. This is a height of 3. This is a height of 4, right? I'm using 2x times my x sub I. 2 times 1/2 is 1. 2 times 1 is 2. 2 times 3/2 is 3. 2 times 4/2 is 4, right? So my area, how did I get, what? Yeah, so x sub I, the first x I want is x sub 1. I want the index to be number 1, first rectangle. And it's 1/2 times I, so 1/2 times 1. So my area is the sum from I equals 1 to 4 of 2x times 1/2, right? So that's 2 times 1. Well, you can see that the 2's cancel, right? So I have 2 times 1 plus 2 times 2. Sorry, I have 1. I won't do it that way. I'm going to factor out the 1/2, and then I have 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4. I'm sorry, it's 20, right? So I definitely get a way over estimate with 10. But let's use 10 rectangles. What's that? Half is my delta x, 2x is my function, and I know I'm just evaluating the function at 1, 2, 3, and 4. Yeah, so I factored out the 1/2, and I'm just doing 2 times 1, 2 times 2, 2 times 3, 2 times 4, each index. Yeah, it's 20, yeah, it should be 20. I have the answer right, but not the right. So let's use 10 rectangles. So the sum of I equal 1 to 10 of f of x sub I times delta x, right? Well, we've already figured most of this out. The function itself is 2x, and delta x is 1/2. So we're really just doing the sum from I equals 1 to 10. Those are rectangles. And the area I'm going to get from it is just x, right? The sum of the indices. Sum of x sub I, better yet. So, sorry, that's not right. I want to keep it as 2x sub I times 1/2, right? No, that's fine. It's the same thing, right? So I get the 1/2, and I'm doing 2 times x sub I, right? But I made a mistake, didn't I? My first x sub I is 1/2, right? I made a mistake. Let me go back here, sorry. Oh yeah, here are my x sub i's, right? So 1/2, 2, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, right? Oh, but in my problem, it's I made a mistake again. I'm sorry. Jeez, Robert. I have to recalculate delta x, right? Sorry. What's delta x now? It's still 2 minus 0, but now instead of over 4, it's over 10. So each width of my rectangle is 1/5. What are my x sub i's? 0 plus 1/5 times I, or better yet, just I over 5, the index over 5. So I want the sum from I equal 1 to 10 of 2 times I over 5. Remember, my x sub i's were I over 5, and my delta x is 1 over 5. I made a mistake in the previous one with 4. Okay, so what can I do here? Well, it looks like I can factor out the 2/5 and then just add up I over 5 from 1 to 10. So 1/5, 2/5, 3/5, 4/5, 5/5, 6/5, 7/5, 8/5, 9/5, and then of course I'm ending at 2 10/5. Oops. Yep. Thank you. Wow, so I get 2 over 25, right? I factor out that bottom 5, and then 6, 10, 15, 21, 28, 36, 45, 55. Sorry, 11, 22 over 5, right? Hey, that's pretty close to 4. 4.4. When am I going to get the exact area? When am I going to get the exact area? When I have how many rectangles? Infinite number of rectangles. So the integral from a to b of f prime of x dx equals f of b minus f of a equals the limit as n goes to infinity of the sum of f of x sub I times delta x from I equals 1 to n. What letter is this? What Greek letter is it? Sigma. So what Greek letter is it? Sigma is what letter in our alphabet? There's a dead giveaway. S. What letter do you see here? S. So the integral is a sum of areas. What does delta x become when I have an infinite number of rectangles? How wide are they? When I have an infinite number of rectangles, how wide are they? How wide are these rectangles? Infinitely small. Guess what we call that? It's on the page. Dx. I need to go back to pre-cal for a second. We'll do another one, okay? I made a mistake with my 4 rectangles, but that's okay. I'll do another one. I need to go back to pre-cal for a second. And if you don't remember using these, you're going to be a little nervous and in shock and all of that. But get over it. Use them, practice. I need some series values. So the series from I equal 1 to n of the constant c is c plus c plus c plus dot 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 plus c. How many times? N times. So the answer is n times c. Right? I'm just adding up c n times, so it's nc. If I add up 5 7 times, it's 35. Right? 7 times 5. The sum of I equal 1 of n of the index I, so meaning 1 plus 2 plus 3 plus dot 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 all the way to n, is n times n plus 1 all over 2. These are all going to be written on your formula sheet and used. The sum of I equal 1 to n of the index squared is 1 squared plus 2 squared plus 3 squared plus dot 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 all the way up to n squared is n times n plus 1 times 2n plus 1 all over 6. Those are usually all I use, but I'll give you one more just in case you wanted to try it. The sum from I equals 1 to n of the index cubed, 1 cubed plus 2 cubed plus 3 cubed plus dot 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 plus n cubed is n squared times n plus 1 quantity squared all over 4. Which one should we demonstrate? Which one would you like me to demonstrate? Anyone? What? Third one, I like it. Good choice. Good choice. Third one. Yeah, you're still writing. It's okay. They're in the book. These are from pre-cal. They're in your pre-cal book. Whether your teacher taught it to you or not, or what you were there that day of school, I don't know. It's not high school anymore, and it's not COVID anymore, right? You got to be serious. You're going to be some kind of engineer or something, computer scientist. Well, computer scientists we all know can take anyway. They could create their own software, hack into Russia, go to school, right? You've got it easy. Us engineers kind of don't have much choice but to go through the school channel, get a job at some corporation, and then, you know, doesn't mean we can't change the world for the good, though, right? We're not doubting that. It's just a little bit more of a narrow pathway to get there. All right, so let's take a look at the sum from I equal 1 to 3 of I squared. Well, I is an index, the first number, the second number, the third number. So I want 1 squared plus 2 squared plus 3 squared. That's 1 plus 4 plus 9. That's 14, right? And this is for n equals 3, right? Yes, you with me? So I want to see if my formula works for n is 3. N times m plus 1 times 2m plus 1 over 6 is going to give me what? 3 plus 1, and then 2 times 3 plus 1 all over 6. That's 3 times 4 times 7 over 6. Uh-oh, 12 times 7 over 6, 14. Ha! You prove these in pre-cal using something called induction. Does that sound any familiar to anyone? My computer scientists really need to know induction. When you take discrete structures, you'll do a whole section on proofs by induction. Does proofs by induction sound familiar to anyone? Hello? You can tell me no. It's fine. No. 3, 4 no's. How many ayes? If there's 4 no's, there's 5 no's. It's got to be 10 ayes, I hope. It's a joke. 5 no's. So the proofs should have been done in pre-cal. You certainly can look up the proofs of proofs by induction, right? You can look that up. You'll find all of these series done. For my computer scientist, I would say definitely do it. When you go to discrete structures, you will be doing proofs by induction, okay? Discrete structures is one of the 2 classes, math classes you take after Calc 2. Calc 1, Calc 2, linear, and then, and in any order, linear algebra and discrete structures, okay? And we'd like to do all of this before you transfer for my computer scientists. Okay, here we go. You ready? Let's do another area problem. Let's do the integral from 1 to 3 of, 2x plus 1 dx. Of course, we could get the picture pretty easy, right? What's the height of the function at 1? Good, 3. What's the height of the function at 3? Good, 7. So we are getting this area. Let's do the definite integral first. So what do I get for antiderivative of 2x? Well, we did it already, right? X squared, right? And what's the antiderivative of 1? X, good. And we're going to evaluate where? At 3, at 1, and then subtract the values. So I get 3 squared plus 3 minus 1 squared plus 1. So I get 9 plus 3 minus 2. I get 12 minus 2, that's 10. Before I go further, I'd like to check in on Desmos. Everyone okay here? I'm not taking a break today, but if you need to take a break, go for it. I'm recording everything, okay? So let me check in on Desmos. So I'm going from 1 to 3, sorry. Of 2x plus 1, close parenthesis, and then I want to get rid of this, and then dx, right? And there it is, 10. How we doing? We okay? There's a way to check this on your calculator too, so you can feel free to look that up. I'd rather you use Desmos during the test. It's quicker, cleaner, right? So now I'd like to look at this area with my limit. So we're going to do the limit as n goes to infinity of the sum from I equals 1 to n of f of x sub I times delta x. Don't let me run you over. Stay with me. If I'm going too fast, stop me. I am your Uber driver. If you ask me to do under the speed limit, I'm going to have an issue with it, but certainly it's okay to ask me to slow down if I'm going too fast. How do I find delta x? Every time. Every time. B minus a over n. So 3 minus 1 over n. Since I'm letting n go to infinity, I don't have a fixed number for n. So what is that? 2 over n. I have a formula for x sub I. It's always a plus delta x times I. And so in this case, x sub I is 1 plus 2 over n times I. Everybody with me? Everybody with me? Thank you. I want to find f of x sub I. I didn't do that before because I had so few rectangles I could just tell you the height of the rectangle. So, but from now on, I want a general version of the function at x sub I. What was the function? It's 2x plus 1, right? So, but inside of there, I'm putting in my x sub I, 1 plus 2i over n. I'd like to simplify that. It's pretty easy, right? I get 2 plus 4i over n plus 1. So I get 4i over n plus 3. And that's the height of my rectangle, each rectangle. So I already know that my integral has a sum of 10 from 1 to 3 of 2x plus 1 dx. And I'm looking at the limit as n goes to infinity of the sum of I equals 1 to n of 4i over n plus 3 times, what? 2i over n, right? F of x sub I times delta x. Oops, sorry, 2 over n, not 2i over n. Right? Double check, yes. Delta x is 2 over n. How are we doing? Watch what I'm going to do. I'm going to take the limit as n goes to infinity, and I'm going to distribute here. So I get 8i over n squared plus 6 over n. Now these are just sums, right? So I could do the whole thing summed up, or I could do each part summed up. And that's what I'm going to do. I'm going to distribute the sum here. I have the limit as n goes to infinity of the sum of 8i over n squared plus the sum of 6 over n. What variable is my sum dependent on? What's controlling my sum? Not n. I. So the variable n can be treated as a constant and could come out. So 8 over n squared times the sum of I plus 6 over n times the sum of 1. I is controlling the sum. It's telling me add the first one up, add the second one up, add the third one up, add the fourth one up. But I know a sum of I. I know these two things. I know those two. I just gave them to you, right? So this is the limit as n goes to infinity of 8 over n squared times n plus 1 all over 2 plus 6 over n times n. Right? The sum of I gave you, the sum of 1 I gave you. Yep, so the sum of I gave you we had a formula from pre-cal. This line? Yeah. 8 over n squared is the dependent variable is I. Sorry, it's dependent upon the variable I. So 8 over n squared is like a constant. It could come out. I can factor it out. 6 over n, again, I is the one in control. So 6 over n just comes out as a factor. So let's simplify. What's that? Yes, exactly. Remember, we had a sum of I. I gave it to you, right? I gave you the sum of a constant. I gave that to you. Here. These guys. Say again? I used the second one and the first one, right? If it's the sum of 1, that's 1 plus 1 plus 1, n times. That's n times 1, which is just n. What happens here? It looks like I get 4 over n times n plus 1, and then plus 6. We agree? Eight and 2 cancel, n and n squared cancel, right? So I get 4n over n plus 4 over n plus 6. Looks like I get 10 plus 4 over n. What is the limit as n goes to infinity? Well, 10 stays 10. What happens to 4 over n? Goes to 0, and there it is. Yes. What's the limit of 4 over n as n goes to infinity? 4 divided by a godzillion. 0, right? Yeah, yeah. So this little expression can give me estimates of areas for any number of rectangles. I did 4, then a 10, then 1,000 rectangles. And of course you can tell where it's going. You could guess at the limit. Nice. Let's do some U sub integration, and we'll do one of these every day. Okay, we'll do one of these every single day for the rest of the semester. You will do one on a quiz. You will do one on the final exam. Let's work on our U subs. After today, I'm saying you can do 5.5. Almost all of them now, sorry. 5.5 from 1 to 57. After today, you can do 1 to 57 and 5.5. I am not assigning homework. I'm saying make sure you do all my old exams, right? Make sure you look at all my old quizzes. Make sure you look at my final exam or my chapter reviews. They're all in the folders. So this is level 4. What am I doing in level 4? I'm looking for a function and what? No, looking for the function. You weren't here yesterday. You wouldn't. I don't think you would know it. I'm looking for the function, and it's what? What? Nope. The derivative. I'm looking for the function and the derivative. So u is going to be what? What's the function? arctan. Yeah, arctan of x, right? What's du? What's du dx? What's the derivative of that? One over 1 plus x squared. So what is du? It's 1 over 1 plus x squared times dx. Do I have that? Do I have that? Yes, that's du. What's arctan? U. So now I have the integral of u du. Now, no. Oh, for arctan? No. Don't force things. Let things happen. You're going to have a checklist. What do you mean? Do you see that I'm doing d dx of both sides? Okay. Yeah. We did this yesterday. No, we did this yesterday. Yeah. So what do I get now from my integral? It's now a power rule, right? So what do I get? It's u to the first power. What do I get when I integrate? No, u squared over 2 plus c. I'm integrating u du. It's like x dx. So, but what is u? It's arctan. So I get arctan squared of x over all over 2 plus c. Still level 4. Do you see a function and its derivative? Do you see a function and its derivative? Good. What's the function? ln of x. So u is ln of x. This is my u sub. This is my first level of u subs. I'm looking for the function and its derivative. And I want nothing else, by the way. Nothing else should be there. If it is, I got to do a different method. Okay? So what's du? Dx, exactly. 1 over x dx. I can now make my substitution. I have what? U du. Oh, what is that? U squared over 2 plus c, right? And what is u, though? ln, right? So ln squared of x over 2 plus c, or you'll probably see it written like this in the book, where they make sure you realize you're squaring the entire ln of x. How do we check these? How do we check them? Good. Y prime is what? Well, there's a 1/2 there. I got to bring down the power of 2. Then I reduce the power to 1, and then I take the derivative of the inside, and the derivative of a constant is 0. So my 2's cancel, and I get ln of x over x. Check. Level 5. We ready? Level 5? Please. My dog won't listen to me either, so it gets pretty lonely. We ready for level 5? You're not comfortable yet because you haven't done any on your own yet. Get to work on some chapter 5. Well, no, this is u to the first power. How do you integrate a power rule? You add 1 to the power, divide by the new power. du is the operator. It's this guy in green is the operator. It's saying to you, find my antiderivative with respect to u. It's weird. Like if I had an operator like this, right? What am I asking for here? Square root. So the SQ and the RT are bookending my argument. So square root of 4 is 2. What happened to the root? It's gone. I did it. What happened to the du? I got the antiderivative. That's what the du is telling me. The integral saying get the antiderivative. The du saying when u is the independent variable. Okay, level 5. This is a u sub inside. Our first u sub is function and derivative. U is a whole function. Our second u sub is u is the inside of something. Our third u sub is u is downstairs. Our fourth u sub is anything can happen, but there's going to be some leftover information. Okay? So let's do cos of 3x dx. So I'm going down my list. It's definitely not something I recognize. It's definitely not a power rule. There's no long division or something like that. I see a function cosine. Do I see a sine? No, so it's not level 4. So I'm now on level 5. Is there a clear inside? Good. What is the inside? So u is 3x. What is du? Good. 3dx. Do I have a 3dx in my problem? Say no. Good. So I want to make a 3dx happen by multiplying inside by 3 and undoing it by dividing by 3. If you remember, my level 5 was add nothing or multiply by 1. I just multiplied by 1. But now I recognize, underlined in green, what do I have? Good. And what do I have underlined in purple? Cos of what? Cos of u. So I have 1/3 integral of cos of u du. Oh, this just says, this is now I'm back to level 1. I know this antiderivative, right? I'm back to level 1. I know this antiderivative. Antiderivative of cosine is sine. So sine of u plus c. But u was 3x. So 1/3 sine 3x plus c. Yes? We're going up to level 12, right? So we're on level 5 today. Maybe we'll try a level 6 today. But we're going up to 12 different types of integration methods. When you get to Calc 2, you'll do 12 more. If you're lucky, your teacher will review the first 12. But it's unlikely. You make sure you know Chapter 3 and you know Chapter 5 when you're going into Calc 2, otherwise you're in trouble. This is level 5. Do I have a clear inside? Good. What is it? Yep, u is 1 minus x. What's du? Negative 1 dx. Very good. I need to add a negative inside and cancel it outside. Double negatives cancels, right? So I now have the opposite of the integral of square root of u du. Everybody with me? Say again? How did I do what? So the idea here is if there's a clear inside, let u be the inside. So I did that. I found the derivative of u, right? And then I say, can I make that happen? I can only make it happen if it's a constant, right? So remember, this integral is a sum. Constants move in or out of a sum. I can factor them out, right? Or I could distribute them back in. So that's what I'm doing when I'm doing this multiply by negative on the inside and multiply and cancel it with a negative on the outside. I did. The negative 1 dx is du. Yes. So what do I get? The opposite of u to the 1/2, but I'm integrating, so what do I have to do to the 1/2? Add 1 and divide by the new, yep, and plus c. So I get c minus 2/3 u to the 3/2. And of course u is 1 minus x. So I get c minus 2/3 times 1 minus x all to the 3/2. What do you think? Another one? Number 2. It says the integral of x squared. So this is 5.5, number 2. The integral of, I forget already, x squared times 2 plus x to the 4th, x cubed, sorry. X cubed times 2 plus x to the 4th, all to the 5th dx. This is level 5, right? I'll probably say something to you, like do a u sub on this. And so it is going to end up being a power rule. I could say that the function is 2 plus x to the 4th, but and that's to the 5th, so I'd rather say that there's a clear inside, right? And what is du? Nice. I have an x cubed dx, but I don't have a 4. So I have to multiply inside by a 4 and outside by a 1/4. What do I have underlined in green? Good. And what do I have circled in green? U to the 5th. Good. So I've got 1/4 u to the 5th. I have to add 1 to my power, divide by the new power, and add a constant c. Say again? Yes. So 1 over 24 u to the 6th plus c, and of course u is 2 plus x to the 4th. All right, let's go to level 6. We ready? Say yes. Just say yes for me. Are you ready for level 6? Oh, yeah, sure. Of course. I told you to let me know. Don't let me run you over. I am your Uber driver. If you're a cop and I'm speeding on the way home and you just keep following me home, and then when I get home, you knock on the door and give me 100 tickets, right? That's not the way it should work, right? Pull me over right away, give me the ticket. Don't just let me go so fast that you're lost. Okay? Mike, yes? Yeah. All right, level 6. U sub downstairs. Why do you think we have so many methods? Because they fail. They fail. And so if you go through my list, is it this, is it that, try this, and it fails, you got to keep going in the list, right? So I've got the integral of e to the x all over 1 plus e to the x dx. Is there a clear inside? What's the inside of e to the x? X it's not going to get me much, right? So this one is a clear downstairs. So I'm going to let u equal 1 plus e to the x. What is the derivative of both sides? What is du dx? E to the x. So that means du is e to the x dx. Do I have an e to the x dx? Yep, right? E to the x dx, yes? So I've got 1 over u du. Correct? Yeah? Good. What's the antiderivative of 1 over u? We're back to the beginning. We know this. We know this antiderivative. We knew it a long time ago. ln of the absolute value of u plus c, which becomes ln of the absolute value of 1 plus e to the x, all plus c. Oh, but do I need the absolute value here? No. I don't need the absolute value here because 1 plus e to the x, this is e to the x, that's never 0. Right? This is 1 plus e to the x, never 0, never negative. I want to show you Symbolab. So this is for work at home, not on a test. Symbol AB, Symbolab. So I'm doing antiderivative. Oops, sorry. Let's see, I need a fraction. I need e to the x, right? Over 1 plus e to the x. The nice thing about this, and you'll see it right when I hit enter or go, the first thing it tells me is my u substitution, right? So I think it's supposed to tell me what u is. Let me see if I hit show steps. All you have to do is sign up to get the free version. Just register for it, but it's not giving. Sometimes it gives me my u sub. This one time it didn't. I don't know why. But it's Symbolab. Okay, there's lots of others. Wolfram Alpha. I think MathWave does it. I'm not sure if MathWave is good. Symbolab, Wolfram Alpha. If you sign up for Symbolab, just register for free. It'll give you the step-by-steps. I think that's enough for today. Have a great day. See you tomorrow. Quiz tomorrow.